think we're ready to go. If you're subscribed, you should get a notification now. I just got it. I'm going to go ahead and open it so I can see it as well. You have to forgive my voice. I'm losing my voice. My last class energy is a little high. I don't know. This is how it comes out. So I tend to get a little hoarse after that course. So this is a makeup lecture for my applied stats. My afternoon class is ahead of my morning class, so I'm going to live stream this. And this is intended for my morning applied stats course. Okay, so let me see. The only real notification, the pertinent piece of information is we said exam 1, right? Next Wednesday over just chapter 1. Is that right? So I think that's ready to go. The study guide is loaded. I loaded that in the past couple of days or whatever. So the study guide is loaded on my math lab. Check Moodle. Check the box link and make sure there should be a PDF version in there as well. If not, I can get that in a matter of minutes. But for right now, I'm just going to move forward with today's lecture. So today we're going to continue chapter 2 with section 2.3 on measures of central tendency. So central tendency, all it is how the data or information behaves towards the center or towards the middle, right? So we're just going to be looking at different concepts that are geared towards that. So how to find the mean, median, and mode of a population sample, how to find the weighted mean on the data set, so on and so on, things of this nature, okay? Let's second up a little bit. So central tendency is a measure of central tendency is a value that represents a typical or central entry of a data set. So most common measures of central tendency are mean, median, and mode. All right. So the mean or the average is the sum of all the data entries divided by the number of entries. Okay. Thing about the average, it can be a little misleading, right? Say you have this company, I don't know, say the average. Say the salary for the employees is like $10,000 a year or something like that. But then you have one employee or two employees that make $200,000 a year. So say you have 8 employees at $10,000 and then 2 employees at $200,000. What's the average of those numbers? Right? Say it again. So say we have like 8 employees that make $10,000 a year and then 2 employees that make $200,000 each. All right? What's the average of those? Just, so let's look at it. Clear. So we said 8 times 10, 1, 2, 3, plus what? 200, 1, 2, 3. We get our answer, then we're going to say divided by how many people total? 10. 8 and 2 is 10, right? Divided by 10. So then, you might have a pamphlet or brochure or something about your company and say, oh, the average salary is the average salary of our employees is about $50,000 a year, but that's not a fair representation of what's really going on. You see the problem with like average, like it kind of gives you a sense of what happens in the middle, but it's not in this context. It's not a fair representation of the dynamics because most people are making like $10,000 there. And there's just a few outliers that's kind of skewing what the average income is in that case. So, just kind of be aware of that. So it's like you want to have more than one piece of information ready to go. You still want to take a look at the average, but then, look at, okay, well, what's the mode? What does mode mean? Mode is like what number occurs the most frequently, like what has the highest frequency. Things of this nature. So you don't want to just rely solely on one piece of data or information. Yeah, exactly. So the average is going to be, you add up your data entries divided by the number of entries. In sigma notation, it's going to be the sum of all x. Add all the data entries x in the data set. A population mean, so when we're talking about a population average, we're going to use this notation mu, the symbol here. I think it's mu. Mu. And basically, you're going to add up all the x's in that population divided by the big N is going to be the number of entries in that you're going to, So add up the entries divided by the number of entries. Sample mean is we're going to denote that by x bar. And it's the same idea. Add up your entries divided by little n is going to represent the sample size. Okay. Keep in mind the copy of this is already on Moodle. It's okay. Yeah. I just remind. Champion doesn't have to be told what to do. I'm reminded. Got that from one of my mentors. So let's see. All right, moving along. So the prices in dollars for the sample of round trip flights from Chicago to Cancun are listed. What's the average of the price of the flights? What would you do with these numbers? Add them up and divide. If you have a spreadsheet software, you can type these in and you can actually crunch it in the spreadsheet. Things like Excel and numbers, they calculate these as well. The calculators do it as well. I can't think off the top of my head how to do that. They have a function. Let me see if I can get it. I think if we go to stats, let me see, somewhere in there. Let me see, calculate. We're gonna get into this. I just don't remember right now. Anyway, let me see, calculate. Yeah. Anyway, I'll just do it manually for right now. So we got 872. I think that's straightforward. I'm not gonna do that one because you know how to calculate average. Is this not clear for anybody? Blink if it's not clear. Okay. I was like, somebody got to blink. She was covering her face because she needed to blink, but she didn't want to get caught. That's so funny. I love that. Okay, but yeah, I think this is straightforward. Nothing ambiguous here. So we're just finding the average. Add up all the entries. We have 7 entries, so divide by 7. We get an average of 527.9. Any questions there? All right. So then the median. Median is like a middle number. So the median is going to be the value that lies in the middle of the data when we put the data in order. So we're going to take our data, we're going to put it in order from smallest to largest or vice versa. If the data set has an odd number of entries, then the median is going to be the middle entry. If they're an odd number of entries, just take the middle number. If they're an even number of entries, we're going to take the average of the 2 middle numbers. Is that okay? All right. I think that's okay. But the main thing here is we keep the repeats as well. Say you have something that's repeating, you keep the repeats. So you're just counting. Put them in order, and then take either the 1 in the middle or the 2 in the middle. All right. I think this is okay. So let's see. We have the prices of the round trip flights from Chicago to Cancun. We actually find the median. Okay, what's the smallest? 388? Give me a color. It's just, yeah, okay. But she was first. She was quick. And she's matching her, outfit. I don't know, she's in the orange mood. Orange. What color? Orange. Yeah, I leave it. It's about pleasure and it's blocked by guilt in a energetic sense. It's about that kind of stuff. So anyway, yeah, I'll let that be. So we got 388, right? All right, so 388, what's next?
397 twice.
Okay, so 2 397s. Then what?
422.
And then?
432. 782.
432, 782. I like that unison. 872. Is that all of them?
Yep.
1, 2, 3, 4, 5, 6, 7, right? Is that it? 3, 6, 7. So then what's the median? Should be 427. It's okay? So when we took the data, we put it in order, and we took the number in the middle. We had an odd number, so we just take the number in the middle. We got 427. You see it in action right there. So the median price of the flights is 427. So the flight price at 432 is no longer available. Now what's the median? So now we have this data. So if we take this, and it says the 432 is no longer available, so I'm just going to copy. Let's see. So let's copy. We want to take that. We're going to paste it right here. Now the 432 is no longer available, so we're going to scratch this. Let me actually back up. I'm going to scratch this. I'm going to scratch this. This moves like this, right? And we're going to get rid of this. Now, tell me about the median. So we're going to do what with these two numbers? Take the average, right? So add them up, divide by 2, and 412, right? So the median in this case is going to be 412. Any questions there? I think this is okay. All right, I'm going to keep moving. So mode, the data entry that occurs with the greatest frequency, whichever entry occurs the most often. If no entry is repeated, then the data set has no mode. If two entries occur with the same greatest frequency, each number is a mode, and it's called bimodal. Okay? All right. So we have the same data. It says find the mode. What number, which one occurs most frequently?
397.
397, remember, because that was the only one that repeated. So the mode should be 397. It says ordering the data helps to find the mode. So if we take the data and put it in order, it helps. Okay. So in this example, it says finding the mode. It says at a political debate, a sample of audience members was asked to name the political party to which they belong. Their responses are shown on the table. What's the mode of the responses? So we have the parties, and then we have the frequency. First of all, can you explain to me what does this chart mean? What does it mean? What is it telling us? No, not what are they asking us to do. What is this chart telling us? Just so like you know, just describe to me the scenario. Somebody had a survey or something, and then what did they do?
They asked people which political party.
Yeah. So there was a group of people that asked them which party. So what does that 34 mean as far as the Democrat?
34% of the population.
Not a lot of people from surveys.
Not percent, but just 34 people out of however many they.
Asked is
34 of the total was Democrat. So then that means 56 were Republican, 21 other, and 9 did not respond. So now with that context, can you tell me the mode? It's trying to lead you to it, and you said the same thing. When I first did this last time, I said the same answer. I said there was no mode because I saw 4 numbers. I saw no repeating numbers. But again, let's look at the context. What this is saying is that you have one Democrat, another Democrat. We have 34 Democrats. Then we have 56 Republicans. Republicans, yeah, because we have 56 R's.
the most frequent.
Yeah, that's the most. That's the high. That has the highest frequency. You see what I'm saying? Yeah. So this one is different than the previous. The previous listed the data. This one is telling us the frequency of the data. So there was a little bit. That's why I kind of did a little precursor on explaining what this chart means, and that what you said was fair, but in this context, this is saying that we have 56 R's. Yeah. Whatever has the highest frequency is the
So
mode.
like per person get answer. So this is kind of all of them, and they all have 56.
Yeah. So the Republicans have the highest frequency in this one. So in this case, the mode should be Republican. Let's scroll. Okay. Not to be, because the last one, those were data entries. Then we were actually looking at the actual data. This one, if we were to look at the data, we would have D, 34 Ds. Then we would have R, 56. Have you heard about that new pirate movie? It's rated R. So
wait, so that's bimodal. It says, I'm looking back at it. It says the 2 entries occur with this great frequency is
bimodal, yeah. This one, it didn't even skip a beat. Like, it didn't even register as a joke. But yeah, this one is a little different. The last one, like the highest frequency was a 397 because it occurred twice. The frequency of that one was twice. This one, we don't have the data. We have the frequency of the data. So then we just had to,
See which one.
yeah, the highest frequency. So the mode is the highest frequency. Okay. So yeah, that was a little bit of a trick question. All right, let's keep going. See, my humor is wasted. That's okay. I'm going to keep trying until I get it. All right, comparing the mean, median, and mode. So all 3 measures describe a typical entry of a data set. There are advantages of using the mean. The mean is a reliable measure because it takes into account every entry of the data set. So it's reliable because it accounts for every entry, every entry of the data. But the disadvantage is that it can be greatly affected by outliers. So that example I did earlier, where we had a company, 8 of the employees made $10,000 a year, then there were a couple of outliers that made $200,000 each. Those were considered outliers. So then they skewed the average. Yeah. Okay. So then it kind of was misleading. It seemed like, oh, if I go work for this company, there's a good chance I can make $50,000 a year. But when you actually look at the data, most people were making $10,000 in that company. And you would extend this to real data, but that was just a simple example to kind of see it. So it's greatly affected by outliers. Okay, so we'll keep moving. So that's on the average. Okay, so we want to look at comparing the mean, median, and mode. In this example, the asks us to find the mean, median, and mode of the sample ages of a class shown. Which measures of central tendency best describe the typical entry of this data? Are there any outliers? Okay. The mean. I kind of want to do that, but I'm not going to. I actually want to do this in a spreadsheet. Yeah, I'm going to do a spreadsheet. You know how to calculate mean, median, and mode. I want to type this in a spreadsheet. And hopefully I don't have any sensitive information that pops up immediately. Go back. Okay. I just want a blank spreadsheet. That's all I want. Yeah. Something like this. What time is it? Started 2. Okay. So let's look at some play. Now this is numbers in Mac. You could do this in Excel. Let's see. I want to see the solutions. It says find the mean. So I want to just get this data. We got ages, and we want to compare the data to the what? I just want this data for right now. So I'm gonna make what could we call the data? Ages, right? So I'm just gonna title it ages, and I just want to type all this out. I got 1, 2, 3, 4, 5, 6 20s, right? So I'm gonna that's the first one copy. 1, 2, 3, 4, 5, and I'm gonna paste. I got 6 copies in, right? Then I have how many 21s? 4. 21. I want to copy and 3 more. Okay. 1, 2, 3 22s, right? Is this right? 3 23s?
No, it's 423.
1, 4 23s?
2 24.
24. Oh no. No. So yeah, I said 24 like that because no, like in high school, I had a teacher. He would always do that. Like he was African. I mean, I really to this day I still don't know why he would do that because he knew how to say the number, and it just boggles my mind. I don't know if he was just doing that just to be silly, but he'll say all the numbers normal. He'll go like 20, 21, 22, 23, 25.
I say 25.
But no, he's like, no, he was like super exaggerated. He was like 1, 2, 3, 5, like every time. And I'm sitting there, I was like, I would look around the room. I was like, did none of my classmates hear this? Like nobody would say anything. I wouldn't see a smirk, a laugh, a giggle, a hee, a ha ha, nothing. I'm sitting there thinking to myself, I was like, am I like crazy? Am I missing something? Like, how come nobody's responding to this? I thought it was the funniest thing. And like to this day, I never like confronted him like why are you doing that? Like were you doing that just to be silly, or do you really not know how to say 4? You know. So anyway, okay. Now, how many data entries should we have? Okay, how many rows are there? How many columns are there? How many columns? 1, 2, 3, 4, 5, 6. 6, right? 6 times 3 is that accurate? No, because there's an empty space. There's an empty one. 18 is 1 too many. So it should be 17, right? Did we do that right? 1, 2, 3, 4, 5, 6, 7 columns. 7 columns? 7 times 3? 21, but 1 is too many? 20, right? We should have 20 data entries. Now, how come there's a 22? How can we account for this 22? Notice on the left here, it says 19, 20, 21. How come we have 22 and there should be 20?
Do we add
I think
one row is not.
no, look,
Yeah.
like, one is like
Yeah, we skipped one at the top. and then the age is counted for another. So if we were to remove those two and moved it up by 2, we would have our 20 like we anticipate. So I was just saying that. So now we got our 20. So that's a thing saying that more than likely we did it properly. So now let's see if we can like synthesize this data. First, let's see if we can find the average. So let's go here to the side. I'm going to label this cell. I'm going to call it mean for the average. No, not man. That's not what I typed. Don't autocorrect. Mean. All right. So now, if you're working in a spreadsheet, this is numbers. You can pretty much do the same technique in Excel with some minor tweaks and it'll work. But say I want to get the average. I'm going to hit equal, and that's going to put it into equation mode. So if you hit equal, it puts us into equation mode. So then if I hit mean, I can type average. You see that at the bottom? I'm going to hit enter. Now it's saying take the average of what? Well, I want the average of all of these cells. All right? Okay, so I'm going to hit enter. So we get that the average is 23.75, right? I'm going to leave it like that. So then it asks us to find the median. So here, I'm just going to label this as median, right? Then I'm going to hit equal. I'm going to hit median. See the option at the bottom for the function? I'm going to hit enter. I want that same data. I just want this data here. And it should give me, what did you get? We got an even number. This is 2, 3. We had an even number of data, right? So we had to take the 2 in the middle. It looks like ours is already arranged, so that would be what? 10 and 11, right? So then, in this case, it would be 21 and 22, right? So you take the average, you get 21.5. Is that okay? Okay. So we got the mean, we got the median, and the mode. What do you think is the mode? 20. Oh, no, that's not what I typed. Mode. Thank you. I'm going to hit equal. I'm going to hit mode. There it is. And I am going to highlight the same data. 20, right? 20. See that? The the graphic calculators can crunch these numbers as well. If you do a quick YouTube search, it'll walk you through how to do that. I'm just not going to do it right this second. But I'm just telling you that the TI-83 Plus and all that kind of stuff, they can crunch these numbers like that as well. We'll see it at some point. Okay. And you should know how to calculate all of these by hand. So I just wanted you to see the spreadsheet data. And what I want to do is move this stuff around. I want to take this. I want to move that like maybe there. And I want to take this and I'm going to move this here. And then that'll allow me to kind of do something like this. Just to blow it up a little bit. This is fine. Okay. So we have 23. Let me see. Solution. The mean, or the X bar, that is the sample mean. 23.8. Yep. Years. Okay. The median, 21.5. And the mode is 20. Questions, comments, or concerns? I got 99 problems, but math ain't one. All right. Anyway, no team or anything like that. Let's see. Moving along. So the average takes every entry into account, but is influenced by the outlier of 65. So that 65 skews it. The median also takes into every entry into the account, and is not affected by the outlier. Okay. In this case, the mode exists, but it doesn't appear to represent a typical entry. So again, the mode was 20, but most people are a little bit older than that. Okay, let's keep going. Oh, this one is. I was like, why am I supposed to feed all of a sudden? All right. So sometimes a graphical comparison can help decide which measures of central tendency best represents the data set. So in this case, it appears that the median best describes the data set. Let's see. So the median, what was that, 21.5? Why that one? Because this would be considered skewed, skewed left. Oh, mean, median, and mode. Okay. So now I'm under the impression that the median best describes the data set in this case, or the central tendency, because it's the one closest, it's the middle one between mean, median, and mode. I think that's the argument there. So you might want to just confirm why the median is the ideal in this case. But I think it's because it's in the middle between the mean, median, and mode. Between those three concepts, it's the one that's closest to the center. I think that's the case. That's what I remember last time. So then just kind of check and make sure. Let's keep going. So a weighted mean. So the average of a data set whose entries have varying weights. So where W is going to be the weight of each entry. So like when I go to calculate the sum of the weights. I mean, yeah, that's essentially what I do. So it says W is going to be the weight of each entry. Yeah, that's fine. Yeah, when I go to calculate your grade, all I do is I take your average for each component times the percentage. And so, but my percentages add up to 1% or 100%. So like, homework might be 10%, quizzes might be 10%, exams might be 60, so that's going to be times 0.6. You know, so when I go to calculate your grades, that's essentially what I'm doing. You know, and it does work. Again, this E symbol is called sigma notation. It just means add up all those entries. So if you add up all the weights, when I go to calculate your grades, it should add up to 100%. And otherwise, you know, the sigma, again, this E symbol here, that one, means summation. Sigma notation means summation. It's going to add up the entries. All right. So let's see it in action. Weighted means. Okay, so we're taking a class in which our grade is determined from 5 scores, 50% from the test average, 15 from the midterm, 20% from the final, and 10 from the computer lab work, and 5 from the homework. Our scores are 86, 96, 82, 98, and 100. What's the weighted average of the scores? If the minimum average for an A is a 90, then we get an A. So I'm going to go back to the spreadsheet. Now you can do it by hand. I want to show you the spreadsheet. All right. I don't really want to see the solution. I just want to see that. Can I clear this? Let me see. I'm going to go all in deletes. Yes, that's all I want. Okay. So, let's see. Say we want to have the final grade here, like final grade, right? And then now the grade is going to come from, let's see, what's the first entry? When we go to calculate the 50 from the exam, right? So we'll say test average, test mean, right? What's the next category? Midterm? What's the next one? Computer.
Homework.
That's it? Okay. I'm going to go and calculate momentarily. We have the averages. That's the weight. What score did we get? 86. So we got an average of 86 on our exams, right? Tell me about the midterm. 96. Okay, this is better. Like, you can't have an average of an exam grade of 50%. And like, can I get an A? I'm like, you didn't earn an A. Like, you know, final exam 82. Okay. 98, and what's the? Okay. All right, so they gave us, let's go ahead and include the weights as well. Let me see if I can, maybe I need to reorganize the data. So let's do this. I'm going to take all of this, right? I'm going to move it down. And what I want to do, can I transpose? I've seen those options. I think there is a way to do it. So, range. Nope. It's just, nope. Merge, autofill. I wanted to I know there's a way to transpose the data where you switch the rows and the column. I just don't immediately know how to do that off here. That's okay. Let's see. I can still work with it this way. And we'll go ahead and put the weights. Just trying to figure out how to label this. So I'll put the weights here. Weights. Okay. So what's the weight for the? I'm not liking the weight. This is fine. It said 50%, right? What's the next one? 15. What's the next one? 20. 5. Is that it? Okay. What should those weights add up to? So let's see. If we say equal, we're going to say sum. Let's make sure that these weights add up to 100. Okay, so they do. I want to get rid of this. Delete that. All right, so they do add up to 100. Now let's see. We're taking a class. We have all the information. What's the weighted mean of our score? So typically, I mean, if we were to use that formula, it just says the first entry times the first weight plus the second entry times the second weight plus so on and so on divided by the total weight. So let's invoke that formula that we see here. Let's invoke this formula. So now we're going to calculate the final grade. We're going to say it's going to be equal to the first entry, I'm going to say times its weight, plus the next entry times its weight. See how that's working? All the way down. Plus this entry times its weight, plus this. Now there are other ways to express this. I'm just choosing one for right now. This times its weight, right? That should be the numerator. So I'm going to put all of that in the parentheses. It's not the most sophisticated way, but it's just a way. Now that'll be the top. We want to say divided by what? Tell me about the bottom. What is this? What does that mean? The E is summation. It means add up. So what is this saying? If we look at the denominator here, what does that mean? Add up the weights, right? Did we do that already? Yeah. So what is that? A7. Let's just say divided by this cell, in case it were to change at some point. Like if we included extra credit or something. Okay. So we added them up. Anybody know what the result should be? Enter 88.6 is correct. Okay. So we did to calculate. You know, we said you saw how we constructed it. The first entry times its weight, plus the next entry times its weight, third entry times its corresponding weight, so on and so on, divided by the sum of the weights. You get 88.6 is their average. So it says, what's the weighted score? So we got an 88.6. If you wanted to round or take the ceiling, it would round to 89. It says, if the minimum average for an A is 90, did the person get an A, yes or no? Okay. Any questions there? So now in this table, theirs is organized a little bit differently, and I think it's a little bit better. They have the source, you see. Then they have the score. Then they have the weight. Then they have X times the weight. They added up that last entry and divided by the sum of the weights. Now they converted them to decimals. The weights were given in percents. They converted the percents to decimals. Okay. But I think you all can catch these changes. I just wanted you to see the spreadsheet in action. Okay. All right. You did not get an A. Okay, I'm going to move forward. Okay, average of group data. We're almost done with this section. Let me see. So if we have a frequency distribution, the frequency are like the weights. So how we just did the weighted average, it's the same idea, but instead of using the weights, you're going to use this formula. Instead of saying X times the weight, you're going to say X times the frequency. So how many times that X occurred And then the little n is going to be the sample size, however many entries you have. Does this make sense? Let's see it in action. In words, find the midpoint, sum of the products, sum of the frequencies. I want to see an example. Okay. So we have this frequency distribution. It says use the frequency distribution to approximate the average number of minutes. Okay. So are they going to use the midpoint? So yeah, they're using the midpoint. So they took the average. Like if you look at class 1, which went from 7 minutes to 18 minutes. This chart, let me see. So these are online times for subscribers. So class 1 is 7 to 18 minutes. The midpoint was 12.5. There were 6 people in that class. The midpoint for class 2 was 24.5. There were 10 people in that class, so on and so on. So we said the midpoint times the frequency of each class divided by the sum of the frequencies. So if we add up all those frequencies, we'll get the 50. So then you see how that, is it clear where that 2089 came from? We add up all the x times f. Is that okay? We get the 2089 divided by 50. So then the sample mean, 41.8. Is this okay? Okay. So then a vertical line can be drawn through the middle of the graph of the distribution, and the resulting halves are approximately mirror images of each other. This is a symmetric distribution. So when the distribution is symmetric, when the data has an even spread, we'll get something like this. You can draw a line down the middle. The left should be a mirror image of the right. That's for a symmetric distribution. Okay, moving forward. Notice about the mean, median, and the mode. So that's a fair representation of the central tendency. Our uniform distribution is going to be rectangular in shape. All entries or classes in the distribution have equal or approximately equal frequencies, and then it's symmetric. So what does symmetric mean? If you cut it, if you cut it in half, one half should match the other. Is this one symmetric? Yes or no? Yeah. Okay. If you cut it in half, what's the basic shape of the half? No. I mean, yeah, I see what you're saying. But I'm saying, like, say you cut this in the middle. What's the basic shape of each half? Yeah, triangle is what I was going for. See, like that's the basic shape there. Is a triangle. Is that okay? And then this is the mirror image of that triangle. Whereas, if you were to cut this in half, the basic shape would be a rectangle. Okay? But I see what you meant when you said Wi-Fi. I was like, yeah, that makes sense. All right, skewed left distribution. This is negatively skewed. So the tail of the graph elongates more to the left. So when we're talking about skew, you gotta, because like to me, my first intuition when I see this, it looks like the data's kind of been pushed to the right, but that's what we mean by skewed left. It's basically where the tail of the data goes. So this is skewed left. Right? Skewed right, the tail kind of goes off to the right. To me, it looks like it was pushed to the left, but this is what we call skewed right. So it's almost, you kind of have to decide how you want to distinguish. Okay? Elongates more. So the average is to the right of the median. The mean is to the right of the median. In skewed left, the mean is to the left of the median. All right. Oh, and that's 2 3. I am exhausted. Okay. I'm going to stop the stream because that ended 2-3. I'm probably going to go ahead and fix my labels, and then we'll just pause for a moment. Okay, so give me a moment.